Hey everyone, we spend so much time agonizing over what we eat, right? But honestly, how often do we stop to consider exactly how it was processed? Today, we are embarking on a bit of a scientific detective story, and it revolves around something that's probably sitting in your kitchen pantry right this second.
So, here is the central mystery we are tackling today. Does the way you grind a superfood actually change its chemistry? Most of us just assume that a powder is a powder. Whether it's chunky or super smooth, it's the exact same plant, isn't it? Well, it turns out that assumption might be completely wrong. We're looking at some really cutting edge research today that suggests the physical act of grinding can actually unlock hidden nutritional superpowers. To figure this out, researchers turned to Moringa oleifera. It's often called the drumstick tree, and its leaves are an absolute nutritional powerhouse. We're talking roughly 25% protein here. That is incredibly high for a leafy plant. Plus, it contains all 9 essential amino acids and a massive payload of vital antioxidants. It's an absolutely crucial plant-based protein source, especially in parts of the world where animal protein is hard to come by.
Now, we aren't just guessing here. This explainer is based on a highly controlled, peer-reviewed study out of Sindh Agriculture University, which was featured in the International Journal of Agriculture Innovations and Cutting-Edge Research. So this is rigorous science looking directly at the physical, chemical, functional, and sensory properties of moringa leaf powder.
Let's dive right into Section 1, the Great Grinding Experiment. The researchers took freshly dried moringa leaves and subjected them to 3 different treatments. Basically, they created 3 suspects for our lineup. Think of this using a coffee grind analogy. It makes it super easy to understand. Step 1 is T1, using a manual pestle. This gives us a coarse texture, kind of like what you'd use for a French press. Step 2 is T2, using a standard blender, yielding a fine powder, similar to your everyday drip coffee. And finally, step 3 is T3, utilizing a specialized grinding machine to create the absolute finest, most uniform powder possible. Think of this as your superfine espresso grind.
Okay, our first major clue is in the yield. The amount of powder you get, the yield percentage, actually decreases slightly as our grinding methods get finer. The coarse T1 pestle method gave the highest yield at 31.31%. But when we look at the T3 grinding machine, the yield drops a bit to 30.25%. Achieving that superfine particle size naturally results in a slight physical loss of material because of the intense grinding process in the machine. But here's the big question. Is that slight loss in physical yield actually worth it? Let's find out in Section 2, Chemistry, Nutrition, and Yield. Notice that clear stair-step rise in available crude protein. Now remember, the plant material itself hasn't magically changed, but by breaking down those plant cell walls way more aggressively with the T3 grinding machine, we are literally forcing the release of encapsulated phytochemicals and macronutrients. Simply put, the finer the powder, the more bioaccessible the protein actually becomes. The available crude protein peaks at an impressive 21.19%, and that was unlocked purely by using the T3 grinding machine. The coarse grind just couldn't reach this level. By increasing the specific surface area of the powder, the grinding machine is maximizing the absolute nutritional payoff of the moringa leaves. And this trend isn't limited to just protein. Carbohydrate content follows the exact same pattern, peaking at 35.71% under the intense grinding of T3. Again, the finer the grind, the more the plant yields chemically. So, that physical loss we saw in the yield stage, it is definitely starting to look like a very worthwhile trade-off. But it's not just about what goes up. We also have to look at what goes down. Finer grinding actually leads to the lowest moisture content, dropping all the way to 6.24% in the T3 sample. Now, in the world of food science, low moisture is a fantastic thing. It means the finer powder has significantly better storage stability. It's going to have a way longer shelf life and be much less prone to spoiling compared to those coarser, moisture-heavy powders. But how does all this lab chemistry translate into real-world use? Welcome to Section 3, Water, Oil, and Function. Before we look at the next set of data, let's quickly define a term you'll see a lot in this kind of research: oil holding capacity, or OHC. Simply put, this is the ability of a powder to trap and bind with lipids. If you're formulating a new protein bar, a functional dietary supplement, or even a therapeutic formulation, you absolutely need an ingredient with a high OHC so it mixes well and stays perfectly stable. The T3 machine grind shows a massive leap here, hitting 3.1 grams per gram. Because the T3 powder has such a tiny uniform particle size,
We're talking ranging from just 20 to 120 micrometers. It has a vastly larger surface area. This increased surface area acts almost like a sponge, trapping fats way more effectively than that coarse pestle grind.
And guess what? The exact same physical mechanics apply to water too. The water absorption capacity, or WAC, hits an incredibly impressive 4.6 grams per gram in the T3 sample. This high hydration behavior is exactly what you want when designing foods or therapeutics, because it means the powder will actually dissolve and integrate seamlessly into your recipe, rather than just floating in a gross clump at the bottom of your glass. But what about the human element?
Let's move on to Section 4, the ultimate taste test.
The researchers actually brought in a semi-trained sensory panel to evaluate the different powders, and they didn't just ask for a general opinion. They used a strict 9-point hedonic scale to judge very specific metrics: visual color and uniformity, the intensity and pleasantness of the aroma, the consistency and mouthfeel of the texture, the perception of the flavor, and finally, just overall acceptability.
And the winner, the T3 grinding machine, swept the board, landing the highest overall sensory score of 7.66. Basically, science and taste completely aligned here. The panelists vastly preferred the smooth mouthfeel, uniform color, and the fully released aromas of the finely ground T3 powder over the gritty, coarse T1 powder. Let's look at the big picture.
Here we are at Section 5, the final verdict.
The most crucial takeaway from all this is the juxtaposition. On one hand, the coarse pestle, T1, gives you a slightly higher physical powder yield, sure, but it essentially locks away its nutrients. On the other hand, the grinding machine, T3, requires a minor trade-off of physical powder loss during processing, but in exchange for that tiny loss, you get overwhelming advantages: the highest available protein, the best water and oil absorption, a much longer shelf life, and vastly superior taste and mouthfeel. The evidence is totally conclusive. Reducing particle size significantly enhances the actual value of the superfood.
As we've seen, a powder is literally never just a powder. The physical process of grinding is an absolute key to unlocking a plant's true potential. So I leave you with this final thought. The next time you are at the store buying a powdered dietary supplement or even just a bag of coffee, will you wonder how it was ground? Will you wonder what nutrients might still be locked inside? Thank you so much for joining me on this explainer today. Keep learning, and I'll see you next time.